I'm going to start showing the current agent demo/docs that we have today, and they all live in this repo that is called XMTP agent examples. So it's a mono repo, and it has a lot of the XMTP best practices and a lot of simple examples, like very minimal. Each example is meant to showcase only one functionality or one feature, or maybe one approach or best practice. And yeah, these are very modular and very small. So the idea is that eventually you have a bunch of examples and you feed them into an AI and you can vibe your way through building like a fully functional agent. So let's go over this repo and some of the concepts to get to know XMTP better. Yeah, so some of the things we are core to the protocol is how we handle keys. For example, like each XMTP identity is associated with a wallet, right? And this wallet, it could also be associated with passkeys, but with agents, we are focusing on Ethereum wallets. So you will need a private key of the wallet, and then you will need an encryption key. The encryption key, because XMTP is end-to-end encrypted, means that messages are not stored online, let's say, and they are downloaded to your device. They are download encrypted, and on your device with your keys, the messages are decrypted. So only on your device, you are able to see the messages. So that presents or introduces a couple of nuances. But yeah, so that's the point of the encryption key is to log your local database so you can do a backup or restore it later. And you always know that you are the only one who has access to that local database, not only with the wallet key, but also with the encryption key. So it's, yeah, a double security measure. For making it easier, we have a script that will generate the random key for you. If not, you can go, for example, to MetaMask. Okay. So in MetaMask, you will have a seed phrase creates you, it's the creator of all your wallets in your MetaMask. So when you create the MetaMask, it's going to make you to say the seed phrase. And then you can start creating accounts. Each account is a wallet. Each wallet is going to have its own public key. So this is how the agent is live on the network. This is the address that people can send a message to. And then this address can be associated with a DNS domain or a base address and so on. And each wallet also has a way to show the private key. So if I enter the password, it's going to export a private key. So yeah, one way is to create the wallet in MetaMask, for example, or any of the other wallets, and then to import it in your XMTP example repo, and that is going to create the XMTP identity. Or another one is to start with a simple random key. So yeah, let's go over that. So I have the repo now here, the XMTP examples repo. I just forked it from GitHub. So if I run gen keys, it just created two keys, random keys. I already have one, but it's creating one over my environment file. The environment file says variables that your agent can use on the backend and are private. So they are not on the code. So this is the wallet key and the encryption key. So now, yeah, I already have this one. So I'm going to do like a yarn dev. And that's it. You just need the two keys, and then the XMTP client is started. Once you have the client started, by default, we are using the GM example. The GM example, it's a very simple example. Let's go over the code. Use the designer, so feeds this, create a designer wallet. So it's basically like clicking sign on a web app or mobile app. So that's how it's done on the backend. So you just need the key, and it's like signing. Once you sign, you then send the signer to the XMTP client creation, and you also specify the network. So we have two networks, dev and production, and we also have a local network for local development. So you would expect to develop on local network, then maybe test it on dev network. And once your app is live or your bot is live, you go to production, which is where the live production apps are currently hosting. So yeah, you will create the client and we will log the agent details. And this is what we are seeing on the console, like a cool XMTP logo, and then the agent details that come from these parameters. So the address is the same address associated with the private key of the wallet. And this is live on the XMTP network, and you can start messaging this agent. The inbox ID is something specific to XMTP. So one inbox ID can have multiple addresses or multiple passkeys, multiple identities. So it's one to many. But once you create an address for an inbox ID, you can think of them as, the same identity, but different identifiers. But the inbox ID is the thing that it's going to, addresses can change, or maybe someone is talking to you for XMTP, but they don't necessarily have a wallet address, but they're still going to have an inbox ID. And in this case, we are using production network, and it's giving me a URL. So a big part also of working with agents is get to know XMTP chat. So XMTP chat is a web inbox we have. And it's a very cool web inbox. It's meant to be used by devs. So it has a lot of details and a lot of concept that the protocol introduces. So in this case, for debugging my agent and for testing it, I can log into XMTP chat. So we will need to log on production because that's the network the agent is running on. And then we can log in with my MetaMask wallet, for example. Or I could log with Coinbase smart contract wallet, or I could log with for ephemeral wallet. I need to cancel. I want to log with an ephemeral. So an ephemeral is creating basically a random wallet for you to use, a temporary wallet. You don't need to know. You can definitely get the address of this temporary wallet. Also, its inbox ID. And you also have installation. So because it's end-to-end encrypted, each device is also going to have its own ID. And we can create a group, or we can create a DM or direct message. So in this case, we have a deep link ready. So if I click on the URL from the terminal, it's going to redirect me to this address, which is the same thing as copy pasting the address and sending a new direct message to this address. And so if I say hi, the agent is going to respond GM, right? So we can see in the logs on the left, we can see the cream was started. This means like a stream is running. The stream is listening for any incoming message, and then it's logging the message that I sent and responds GM. So this agent is going to know who is the sender, what is the message, and then it's able to reply. Same applies for groups. And you will see in the repo, these files that get created, these files are the local database that we mentioned before. And these files are encrypted with the encryption key, and all your conversation messages are going to be stored in this device and in this database. And if this database is lost, your conversations are going to be lost. There are ways to recover them, but in theory, they are lost because they are only stored in that database and they are not stored anywhere else. So this is the GM example. We'll see like after the client creation is making a sync. So it's fetching the network to see if there are any new conversations that we should be aware of. Once it's refreshed with the network, it's going to create a stream. And the stream is basically going to be waiting for messages to be received. And these messages, in this case, because it can be a group or a DM, in this case, we're not checking if it's a group or a DM. It just sends GM on any conversation. And we can also get the address from the one who is sending the message. So in this case, response to this is the address that I created on XMTP chat with the ephemeral wallet. So that's the XMTP agent example. So then you go, if you want to start to build like more like cooler agents, we have some cursor rules. And cursor rules cover a lot of concepts like how to create groups, how to handle all these concepts from XMTP, how to handle encryption keys, guidelines, how to use, because we are using TypeScript, how to use types. So the code is very reliable and easy to read, how to use streams. So the cursor rules is like a big README file, like a big set of docs tailored to AI. You have a lot of code snippets, examples, and ideally this should these cursor rules are going to be available to code about anything on XMTP. So we are going to demo how that works in a second. Maybe I can go over one other example. So we have examples for transactions. We have examples for how to restart stream, like best practices. We have examples for a dual client, which is when you want to receive a stream, what you create two clients with the same wallet key. And one client is expecting the messages, it's only used for streaming, and the other client is used for sending a message. So sometimes if your agent performs like complex tasks, you may want to save that task in a queue that you can process, and once it's completed, then send it to the user. So that processing, and maybe it's more complex, and you will need like a better way to separate that you're still inside the stream versus using like an independent worker for sending that message. We have examples for the NFT gated group. So you can send slash commands. And in this example, it's going to check if the address that is sending the message has certain NFT connection. In this case, we're using XMTP people from one of our engineers, Naomi, and she has a very cool connection on OpenSea. And so if you are an NFT owner, you will get added to this group. Again, all this, because it's interoperable, all the concepts are available for developers. So you can play around with groups, you can play around with adding members, removing members, and so on. Yeah, let's try to build an agent. So we have two cursor rules. In this case, we have XMTP cursor rules, and we also have monorepo guidelines. So this tells the agent how the monorepo is structured, how the folders work, what libraries do you need, what are the best practices for creating an agent in this monorepo. Again, what I do here is to create the agent rule. It's on MDC, is the format that Cursor uses. And I also have a backup in Markdown. So basically it's a copy paste because it's easier to search when you want to search through the whole repo. Search doesn't work very well still on Cursor rules. And yeah, it's better formatted, so it's easier to read, but it's the same. So these are tagged to always by default, so you don't need to mention them or tag them. These are always going to work, both rules. I think I have a README rule on how to write good READMEs, and that's a manual rule. So I need to, in this case, I will need to add the rule in Cursor like this in order to tag this rule. But if not, XMTP and the monorepo guidelines should be enough. So let's create an agent that receives the number, multiplies by 2, and sends a response. And let's see what happens. I'm using always Cloud 3.7 Sonnet. I think it's the best. So he knows about the rules. He's reading the repo. And when I say he, of course, I'm talking about my lovely agent. Learning some context. It's probably a bug on the cursor side here. Okay, while it's thinking, let's check another example. For example, transactions is something that a lot of developers are asking for. So if I go to CD examples, CD XMTP transactions, again, this works like its own little small repo. So I can do yarn dev on the transactions example, and it's going to create the client. Maybe in this case, I have a single environment file that is inside the transaction folder. So the wallet is going to be different. It's going to default to this set of keys. And I'm still on production, so I can create the message to this transaction bot. And this transaction bot is going to show me 2 commands. Again, this is very minimal just to show how it works. But I could do TX1, so I could check my balance. This is going to check for USDC on base Epolia. Base Epolia is indicated here. But I can do TX.1, 10 cents. And it's going to trigger a content type. We call them content types. So by default, everything is a text content type, but then you can send replies, reactions, attachments. And one of those content types is a transaction. So this transaction content type is going to trigger a transaction. I confirm it and then sends me the transaction on the Scan Explorer on base Epolia. And this is, all the code, of course, is here. For this example, we are using a USDC helper. So it has some configurations around how to work with base. What's the token address of USDC? What are the identifiers of either base mainnet or base Epolia? How to use smart contracts to check for the balance. It's a 1,000 lines of code helper that, coupled with the content type, lets you have a fully functional engine with transactions. And so the multiplier is ready. Let's just accept all because we trust. And let's go back. So let's go back to example folder now. I want to get inside multiplier number. And I'm going to run yarn dev as is. Okay, first we do yarn, so the packages are updated. Let's try again, yarn dev. Okay, I'm missing wallet key, encryption key, and because I'm inside this folder, it's going to wait for me to set the key. So again, I can run yarn gen keys. So it created me the M file. Super simple. You don't need to go to MetaMask. You just have a wallet. It's also logging your public key. And now we do, again, yarn dev. Okay, so it looks like it's live. Now it's on dev network. And this is the address of the agent. So let's switch to dev network. Again, I'm going to create an ephemeral. And I'm going to send a message to this agent. So we vibe coded this agent in order to get a number to be multiplied. So as we can see, it created the index file with XMTP best practices, very short index file. It created the package JSON, also based on the monorepo guidelines. As you can see, it's aware of the location of the folder. It's aware of how to name the example. It's aware of which libraries to use. In this case, it's using the libraries from the monorepo root configuration, and also knows how to run the yarn keys command and so on. And it also polished a nice README that explains what the agent does and how to run it. So the README is part of the guidelines. It also understands that because I have a README in each example, probably a README makes sense. And gives you an example and the. Okay, so this is my GM boss. If I say hi, okay, it's asking me for a number. So let's send 10. Okay, so 10 plus 2 is 10. 5 plus 2 is 10. Maybe we can try to break the bot. It didn't took the decimal. Yeah, it did. It also parses decimals. So and we can see the logs on the left. And that's how easy it is to create an agent with XMTP. And you can just keep coding here. It's going to be aware of how to work with groups. It's going to be aware of more complex concepts. And this is everything that it did actually. Like, it's taking the message content, parsing it as a float. If it's a number, then show the number. If it's not a number, please send the number. And this code looks solid. And then you can, of course, export this, work on your own repo. We have a standalone cursor rules as well. So if I go to GMBot, The GMBot is standalone, so it's not using a mono repo setup. So this is more similar to what you will do if you deploy a bot. And it has its own cursor rules on how to build a bot that is standalone. So now it's a little bit different. You need to specify the libraries. You don't use the root libraries from the mono repo. You also need to specify some TypeScript config. And yeah, again, more examples. But again, this is not something that you should worry about. This is all handled by the AI. And once you have the repo, then you can go, for example, to platforms like Railway, which is very simple to set up an agent. So I can just do gmbot is importing the repo from GitHub, and you can just deploy it and it will just go live and be listening for any incoming messages on the net. So yeah, that was Vibe Coding 101. Again, everything is on the agent examples repo.